Okay, I'm going to give you an overview of the physics module. The products that we're going to talk about in physics, the physics, the concepts of physics that are going to be important in the products, and the engineering, the role of engineering. Okay, the two products in the physics module we're going to talk about are airplanes, if you will, and I shouldn't say products, but the material that I use in the construction of the product called airplanes. So the two things we're going to talk about. Okay, it's amazing. I mean, right? These really heavy objects that can fly for hours, made of heavier than air. How does that happen? How it actually happens? So we'll talk about a very important principle called Bernoulli's principle, which will help us understand how airplanes can fly. We'll take a look at an equation called Bernoulli's equation, which is the conservation of energy equation. And then we'll take a look at the material of construction used to make the airplanes, and try to answer the question why they're made of, say, metals, composites, for example, as opposed to, say, concrete. Is it possible to have airplanes made of concrete? Highly unlikely. It's not going to survive sort of stresses of trains and things. Concrete doesn't have the properties, right properties, to actually build an airplane, but aluminum does. And composites also do, and composites actually are better than aluminum, for example. So we'll take a look at that. Some of the engineering concepts we're going to look at are issues like strength to weight ratios. What is the advantage of combining different materials together, like composite materials, for example? Why do we get some amazing properties when we combine materials together? In particular, the 787, for example, is made of composites. So we'll take a look at some energy balances, and we'll briefly take a look at what is the difference between rockets versus airplanes. The principle is different, but in both cases, we are using fuel to burn, and then to create the mechanical energy in order to move something, if you will, through a distance. In the materials of construction, we'll take a look at difference in properties with the composites and steel and so on and so forth. We'll take a look at strength to weight ratios, as I mentioned in the last slide, advantages of combining different materials and so forth. Energy balance, we'll take a look at briefly energy balance. Essentially have an equation that allows us to calculate, show the relation between lift and velocity of air flowing past a wing, for example. And so what's also interesting is that you see two, this is the air wing, for example, and this is actually a yacht, right? So some of you might have noticed, or maybe you wonder, how is it possible for a yacht to go where the air, against the wind, as it were? And similar principle applies. So if you understand how a plane flies, we can actually understand how a yacht is able to move what appears to be against the direction in which the wind is actually blowing. You would think that, and the way it really has to do with directing the airflow around the wing in the case of airplane, and the sails in the case of these sailing boats, for example. And we'll talk a little bit about that. And we'll briefly talk about the choice of materials, concepts like strength to weight ratios, the ability to make shapes, for example, is also important. You could have a material that has a wonderful strength to weight ratio, but if you can't work with it, using it in manufacture, then it's not going to be very helpful. And of course, the durability and resistance to the environment. I mean, if you make several tens of millions of dollars of airplanes, you want that to last a long time. We have planes that have lasted for like 30, 40 years, for example. So what gives them the durability is the ability to resist the environment, keep the property. That's also very, very important. So in physics, we'll talk about airplanes, we'll talk about related sailboats and so forth, and about the materials construction, some of the properties of the materials that will make it suitable for airplanes, and we'll talk about the energy equation, Bernoulli's principle, and so forth.